this class, we are going to be discussing October-November 2023 variant 5.2 of Probability and Statistics 1. The first question is, a competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceeds 30 meters. The probability distribution table for x is shown below. We have been given the probability distribution table. We have also been given the expected value of x, that is 1.1, and we need to find the value of p and r. So think for 1 minute what needs to be done. You're going to get you need to form two equations in terms of p and r and solve them simultaneously. One equation would be that the sum of all the probability must add up to 1. So 0.4 plus p plus r plus 0.5, 0.15 should be equal to 1. So the first equation would be p plus r equals to 1 minus 0.55, that is 0.45. And the second equation would be E of x, expected value, that is equal to sigma xp. So 0 times 0.4, that's 0, 1 times p plus 2r plus 3 times 0.15. The expected value is given to be 1.1. 3 times 0.15 is 0.45 plus 2r equals to 1.1. Solve for r. 1.1 minus 0.45 is 0.65. So r 2r plus p equals to 0.65. That's the second equation. This is the first equation. Just solve the two equations simultaneously. So p comes out to be 0.25 and r comes out to be 0.3. These are the values. Okay. Please let me know if there are any questions. Done? Is everyone done with this question? Okay. Find the numerical value of variance. Variance is the expected value of the x squared minus the square of the expected value. Now, in the question, we do have this value. We need to find the expected value of x squared. For that, we'll have to square the x values. X squared would be 0, 1, 4, and 9. So 0 plus 1 times pp plus 4r plus 9 times 0.15 minus 1.1 square. Now plug in the values of p and r. P is 0.25, r is 0.2, 9 times 0.15 is 1.35 minus 1.1 square. 1.35 plus 0.8 plus 0.25 is 2.4. 2.4 minus 1.1 square. So I'm getting 1.19 as the variance. Please check your answers as well. Are we clear with this? Okay. Question number two. George has a five. George has a fair five-sided spinner with sides labeled 1, 2, 3, 4, and 5. He spins the spinner and notes the number on the sides on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. Fewer than 7 spins to obtain a 5. Okay. So how are we going to attempt this question? It's a fair five-sided spinner. These are the numbers. He spins the number and notes the number on the sides on which it lands. We need to find the probability that it takes fewer than 7 spins for Josh to obtain a 5. So if I define my random variable x, it is the number of spins required to obtain a 5. Now he's going to spin the spinner unless he gets a 5. And the question says find the probability that he takes fewer than 7 spins. So this is an indication that it's kind of a geometric distribution. It's a geometric distribution. Okay. All right. Now, how do we find probability of x less than 7? He can get he can get a 5 in the first attempt, or he can get a 5 in the second, third, fourth, fifth, sixth attempt. It has to be less than 7 attempts, 7 spins to for him to obtain a 5. Okay. Probability of x less than 7. Okay. What is the probability of obtaining a 5? Its probability of success is 1 out of 5. It's a fair spinner. The probability of failure would be 4 out of 5. All right. Now we need to find probability of x less than 7. So x less than 7 would be either you find out the probabilities from 1 to 6 and add them up, or you remember the short formula 1 minus q to the power of r. The probability of x less than 7 would be 1 minus q, that is 4 upon 5 to the power of 6. See, probability of x less than 7 means probability of x less than equal to 6. Okay. And probability of x less than equal to 6 was 1 minus q to the power of 6. That's going to be 1 minus q to the power of 6. So 1 minus 4 to the power of 5. That is 0.738. Is the working for the first part here? Geometric distribution, okay? This was a question on geometric distribution. Okay. Part B. George spins the spinner 10 times. So we exactly know the number of times he is spinning the spinner. We need to find the probability that he obtains a 5 more than 4 times, but fewer than 8 times. Now, since there are fixed number of attempts, you can consider this to be a binomial distribution. There are 10 attempts, and our success probability is obtaining a 5. And the probability of obtaining a 5 is 1 upon 5. The question says find the probability that he obtains a 5 more than 4 times, but fewer than 8 times. That includes he can obtain a 5, okay, 5 times, 6 times, or 7 times. Okay. So if you want to calculate the probability of x equals to 5, that's going to be 10c5. 1 upon 5 is 0.2. Okay. 1 upon 5 to the power of 5, 4 upon 5 to the power of 5, plus 10c6, 1 upon 5 to the power of 6 times 4 upon 5 to the power of 4 plus 10c7, 1 upon 5 to the power of 7, 4 upon 5 to the power of 10 minus 7, that's 3. Please evaluate this result for me. Give me the probability. Okay, MR says 0.0327. Okay, so that's the answer. All right. Moving on to question number 3 now. A factory produces a certain type of electrical component. It is known that 15% of the components produced are faulty. A random sample of 200 components is chosen. Use an approximation to find the probability that more than 40 of these components are faulty. So what is X over here? Number of components that are faulty. And it's the number of components. Obviously, X represents a discrete data. Okay. But we need to use an approximation. The reason we need to use an approximation is that we need to find a probability that more than 40. So out of 200, more than 40 would mean probability of 41, 42, up till 200. So this is a lot of probabilities to calculate through binomial distribution. So the approximation that we are going to use is a normal approximation. To use normal approximation, we need to make sure that the conditions of the normal approximation are fulfilled. That is, NP and NQ must be greater than 5. N is 200. There are 200 components, and the probability that a component is faulty is 0.15. So 200 times 0.15 is 30, and 200 times 0.85 is 170. Both values are greater than 5, so we are going to go for normal approximation. Okay. Now, to find normal to solve this question through normal approximation, we need the mean and the standard deviation. The mean is going to be NP, and the variance is going to be NPQ. Guys, there are marks to calculate all these values, okay? So variance comes out to be 25.5. So I'm going to say X follows a normal distribution with mean 30, and the variance is going to be square root of 25.5, the whole thing square. Okay, now I need to find the question says find the probability that more than 40. At this step, I'm going to do the continuity correction. Greater than 40 would mean that you are going to take X greater than 40.5. If I draw the bell curve, the mean is 30. 40.5 value would be here. I am interested in the area that is greater than 40.5. This is the tail area. So using the normal distribution table, I'll be able to find the body area. First, I need to convert this into the Z value. 40.5 minus 30 divided by sigma. 40.5 minus 30 divided by square root of 25.5. The Z value comes out to be 2. Probability of Z greater than, the Z value comes out to be 2.079. So now you're going to go back to the table and read the body area at 2.079. Okay. So let's go back to the table and read the data at 2.079. 2.079 would simply mean 8. 2.07, 2.07, no, this is 2. Yeah, 2.07, okay? Not 2.00, 2.07, 0.9808 plus the ninth value 0.0004, that's going to be 0.9812. That's the body area. 0.9812. Now the area that we want is 1 minus 0.9812, which is 0.0188. Okay, that's the correct probability. Please let me know if you have any questions till here. If it is clear and you don't have any questions, just write in the chat box done. Oh. Question number 4. The heights in centimeter of the 11 players in each of the two teams, the aces and the jets, are shown in the following table. These are the heights of the 11 players. And we have to draw a back-to-back stem and leaf diagram to represent this information with the aces on the left-hand side of the diagram. So back-to-back stem and leaf diagram looks like this. Aces team is going to be on the left and jets are going to be on the right. Okay. For aces, the least value is 164. Okay. And the highest value is 182. Okay. For jets, the least value is 166 and the highest value is 190. So this gives us an idea कि किस तरीके से हमें ये stem leaf plot करना है. The starting value in the stem, this part is called the stem, this part is called the leaves. In the stem, we are going to have just a second, guys. So we have two teams. The smallest height of aces player is 164. Okay, so let's fill in for aces team. So the stem value can have more than one digit, but the leaves will always have one digit. So the stem values are going to be 16, 17, 18, and 19. And for aces, the smallest is 164, then 166, 168, and 169. Then 171, 173, 174, and that's it. Then 180, 181, 182, and 182 is being repeated 2 times. That's it. Okay. Now for jets, it's 166, 168, then 170, 174. 174 is being repeated two times. Then 175. Here have 181. Then 181 again. Then 188. And then 188. And finally 190. So each team has 11 players, and this is the distribution of their heights. Now, one thing is important over here, and that is the key. You are going to get a separate mark for mentioning the correct key. Okay, the key is going to, and for both, key for both. Okay, so there are going to be 2 marks. You can say there are going to be 2 marks for the correct key. Okay, so I'm gonna say that 17/1/0. Okay, this is what I'm trying to represent. Means 171 centimeter for aces and 170 centimeter height for the jet. Is the first part clear? Okay. Now, moving on to the second part, find the median and the interquartile range of the height. Median is the mid value, okay? And we need to find the median height for the aces. There are 11 members, so let's find the median position first. There are 11 members, okay? So n plus 1 upon 2, that's 11 plus 1 upon 2, that means 6th position where your median is going to lie. So the value at the 6th position is 1, 2, 3, 4, 5, 6. 6th position is 173. So the median is 173 centimeters. Then for interquartile range, we need the upper quartile and the lower quartile. The lower quartile is the median of the values before the median. So इस median से पहले there are 5 values. In 5 values the median जो होगा that is your lower quartile. So in values का जो median है that's going to be 168. और upper quartile होगा मीडियन के बाद वाली वैल्यूज का मीडियन. तो ये मीडियन के बाद देयर आर 5 वैल्यूज. इनका मीडियन क्या होगा? It's going to be at the third position, that's 181. So upper quartile, interquartile is defined as upper quartile minus the lower quartile. Upper quartile is 181 and the lower quartile is 168. So you take the difference. Interquartile is 13 centimeters. Does it make sense? Abdullah and Rafi, is it clear? Okay. Give one comment comparing the spread of the heights of the aces with the spread of the heights of the jets. Okay. So we know the interquartile range for aces. Okay. We need to compare the interquartile range for the jets as well. Now, if we find the interquartile range of the jets, okay, the median of the jet would be at the 6th position, 1, 2, 3, 4, 5, 6. That's the median. The lower quartile over here would be 170. The upper quartile over here would be 188. Okay. So the interquartile range for jets would be 188 minus 170. That's 18. Now, who has a more spread? जिसका interquartile range ज़्यादा होगा उसका spread ज़्यादा होगा. So comment comparing the spread of the heights of the aces with the spread of the heights of the jets. The spread of the heights of aces team is 13 centimeter. The spread of the heights of the jets is 18 centimeter. So you are going to conclude jets team have a greater or greater spread of heights. Okay. And if it was a 2 mark question, then you could have given the reason. Okay. For example, Jet's IQR is 18 centimeter, Ace's IQR is 13 centimeter. So the more the spread, the greater the interquartile range, the more the spread. Okay. Now, if we would not have found out the interquartile range, how would we can compare? We can also compare by the range. So over here, range for ACEs would be 182 minus range would be 182 minus 164. Highest value minus the lowest value, that is 18. और यहाँ पे इनकी range जो होगी, that's going to be 190 minus 166, that's 24. So jets have a higher range. Higher range means higher spread. Okay, इस तरह भी compare कर सकते थे. All right. Question number 5. The heights of the members of the club are normally distributed with the mean 166 and the standard deviation 10. So x represents the height. X follows a normal distribution with mean 166 centimeter and the standard deviation is going to be 10. Find the probability that a randomly chosen member of the club has a height less than 170. So if I draw the bell curve, normal distribution curve, the mean is going to be 166. The value of 170 is going to be above the mean. We need to find the probability that it's going to be less than 170. So we need to find this region, this area. So first we are going to find the z value. 170 minus 166 divided by sigma, that is 10. 170 minus 166 divided by 10 is 0.4. The probability of z less than 0.4. Now we are going to go back to the table and read the body area at 0.4. So at 0.4, the body area is 0.6554. 0.6554. Okay, so that's the correct answer as well. 0.655. Any query in part 1? Please let me know right now. So that's the working for the first part, okay? Do we have any questions? Oh. Second part, given that 40% of the members have height greater than age, find the value of age correct to 2 decimal places. Now, it is given that probability that the height of the member is greater than age is 0.4. So if I draw a normal distribution curve, the mean is 166. Where do you think this age value would be such that the area above 8 centimeter is 40%? Should the value of age be towards the right side of 166 or towards the left side of 166 so that the area above age is 40%? Give the answer in the chat box, please. Do you consider age to be on the right side or do you consider age to be on the left side? Right. Good. So H is going to be over here such that the area or the probability above H centimeter is just 40%. So if the tail area is 40%, what's going to be the body area? 0.6. Now we are going to use the table in the reverse order. What we are going to do is we are going to find the z value when the probability or the body area is 0.6. So we are looking for 0.6 as a probability, okay? Okay, 0.6. So the closest value for 0.6 is 0.5987, and I will have to add 13, right? I'll have to add 13. So the closest value would be 12. So the correct Z score would be 0.253. 0.253. So this Z value would be 0.253. So H minus 166 divided by sigma was 10. The Z value is positive 0.253. Solve for H. So 0.253 times 10 plus 166, that is 168.53. So there are 40% of the members who have a height greater than 168.53 centimeters. Is the working clear? Are we good till here? Okay. Now part B says that the random variable x is normally distributed with mean mu and the standard deviation sigma. Mean is mu and the standard deviation is sigma. Given that sigma is 2/3 of mu, find the probability that a randomly chosen value of x is positive. We want probability of x to be positive, meaning x must be greater than 0. Okay. So this is mu, and we want the value of x to be positive. Okay. So positive means greater than 0. So the z value for this is going to be 0 minus mu upon sigma. Okay. Probability that z is greater than 0 minus mu upon sigma. This is what we need to find. And what is sigma? Sigma is 2/3 of mu. So replacing sigma as 2/3 of mu, mu cancels out. So z value comes out to be minus 1 divided by 3 upon 2, that is minus 1.5. So since the z value is minus 1.5, that means that the value of 0 is towards the left side. तभी उसका z value is negative. Now I want to find the probability of z greater than minus 1.5, which is this area. So you're going to go back to the table and read the body area at 1.5. The body area at 1.5 comes out to be 0.9332. 0.9332. So the answer comes out to be 0.933. That is the working for part B. ठीक है? Clear? Any questions in this? Okay. Question number 6. Freddy has 2 bags of marbles. Bag X contains 7 red marbles and 3 blue marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddy chooses one of the bags at random. A marble is removed at random from that bag and not replaced. A new red marble is now added to each bag. A second marble is then removed at random from the same bag that the first marble had been removed from. Draw the tree diagram to represent this information, showing the probability on each of the branches. So guys, first we are going to select the bag. Either you go for bag X or bag Y. And they both have the same probability of being selected, so half, half. Now in bag X, there are red marbles and blue marbles, 7 red marbles and blue marbles. What you are going to do is you're going to pick up two marbles at random. Okay. So the first marble can be a red followed by a blue or a blue. If the first marble is a red, then the second marble can be a red or a blue. If the first marble is a blue, the second marble can be a red or a blue. Same thing for bag B, bag Y, red, blue, and then red, blue, red, blue. Okay. But let's see how the probabilities are going to be written. Okay. I'm going to read this statement again. First, he chooses one bag at a random. Then a marble is removed at random from the bag and not replaced. So it's without replacement. A new red marble is now added to each bag. Okay, so what is the probability of selecting a red marble in the first attempt? It's 7 upon 10. And the probability of selecting a blue marble is 3 upon 10. In bag Y, it's 4 upon 5. And blue marble probability is going to be 1 upon 5. Now, once the red marble has been picked from one of the bag, a red marble is now added to the bag. Now, if you have removed this and added another red marble, so the total number of red marble is still going to be the same. That is going to be 7. And there were 3 marbles blue, so 3 upon 10. Okay. Now, if the first marble was a blue and you have removed it, there are 2 blue marbles left, and you have added another red marble. So total marbles are 10, out of which 2 are blue, and now 8 are going to be red. Okay. If you were dealing with bag Y, and if you have removed the first red marble and then added another red marble, so the total number of marbles is still going to be 5, and there are you have removed one of the red marble and added another red marble, so the total number of red marble is still 4, and the total number of blue marble will be 1. But if you have removed the blue marble, so now in bag Y there are no blue marbles, और आपने एक और red marble add कर लिया है, सही है? तो अब total तो 5 होंगे, लेकिन all of them would be red, and there is no blue marble left. This is the tree diagram. Please look at the tree diagram and let me know if you have any further questions. Okay. Now the next part says, find the probability that both of the marbles removed from the bag are of the same color. So same color means it can be from bag X, red and red, bag X, blue and blue, bags Y, red and red, and bag Y, blue and blue. Okay. So we are going to add these probabilities. Probability that it's from bag X and are red red. Probability that it's from bag X and blue blue. Probability that it's from bag Y and red red. And probability of Y from blue blue. Okay. But we know that this is 0. Okay. Because since this our probability is 0, 0 multiplied by any probability, that's going to give you 0. Now, the first answer would be half times 7 upon 10 times 7 upon 10. Half times 7 upon 10 times 7 upon 10 plus half times 3 upon 10 times 2 upon 10 plus half times The probability of red is 4 upon 5 into 4 upon 5. Calculate this answer. Okay, I'm getting 119 upon 200. That is 0.595. Make sense, everyone? ठीक है यहाँ तक? Let me know in the chat box if it is clear or not. Rafe, any questions? Abdullah, any questions for you? ठीक है. Part C says find the probability that bag Y is chosen given that the marbles removed are not the same color. Okay. So we need to find this is the conditional probability that bag Y is chosen. Bag Y is chosen. Y, given that the marbles removed are not same color. So in the denominator, you are going to have the probability of not same color. That is 1 minus the probability of having the same color. And in the numerator, it should be an intersection of bag Y and same color. Okay, so for the denominator, it's simply going to be 1 minus the probability of same color, that is 0.595. Okay, in the numerator, it should be bag Y and same color. Bag Y and same color is Y red, half times 4 upon 5 times 4 upon 5. Half times 4 upon 5 times 4 upon 5. Oh, sorry. It should be not same color. Okay, please make a correction over here. It shouldn't be same color. It should be different color. Okay, my bad. So in the numerator, it should be different color. Bag Y and different color, meaning red blue and blue red. That's the word. So 1 upon 2 times 4 upon 5 times 1 upon 5 plus 1 upon 2 times 1 upon 5 times 5 upon 5. So the probability would be 1 upon 2 times 4 upon 5 times 1 upon 5 plus 1 upon 2 times 1 upon 5 times 5 upon 5. So I'm getting 4 upon 9 as the final answer. Okay, that's the final answer. यहाँ पे समझ में आ गया? It was probability of finding a probability that the marble is from bag Y, given that it's not the same color. So denominator it should be probability of not the same color. That's simply 1 minus the probability of same color. In the numerator, it should be from bag Y and not the same color. That means it can be from bag X and, oh, sorry, it has to be from bag Y and red blue, or bag Y blue red. Okay. Okay. Now question number 7. Find the number of different arrangements of the 9 letters in the word Andromeda in which no consonant is next to another consonant. The letter D, M, N are consonants, and the letter A, E, and O are not consonants. Okay. So A, O, E, A, vowels. N, D, R, M, D, okay, consonants. So there are two Ds and there are two A's. The restriction is find a number of different arrangements of the 9 letter words in which no consonant is next to another consonant. So it has to be consonant followed by a vowel. Okay. No consonant is next to another consonant. So consonant, vowel, consonant, vowel, consonant, vowel. Okay. Consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant. You can't start with vowel because if that's the case, then the two consonants will be together at the end. Because there are less vowels as compared to consonants. So the 5 consonants can arrange in 5 factorial. The 4 vowels can arrange in 4 factorial ways, divided by 2 factorial for the 2 A's and 2 factorial for the 2 D's. So this is equal to 720. Is the working for the first part clear, guys? Okay. Now, for the second part, find a number of different arrangements of the 9 letters in the word in which there is an A at each end and the D's are not together. Okay. Beside D's, if you remove the D's, there are going to be 7 letters. 1, 2, 3, 4, 5, 6, 7. A has to be at the end. And D's have not to be together. D's are not to be together. So D, possible positions for D's are these. D can be anywhere between the other letters. So 1, 2, 3, 4, 5, 6. There are 6 positions. Out of these 6 positions, you are going to choose 2 positions for D's and arrange D's in 2 factorial ways. Okay. Multiply by 2 factorial for the 2 A's. Multiply by 1, 2, 3, 4, 5. 5 factorial for the other 5 letters. But divided by 2 factorial because the 2 A's and the 2 D's are exactly identical. So let's evaluate this result. I'm getting 1800. Okay. This is called a separator model. I have taught in my classes. This is a separator model. If you want to separate two things, if two things cannot be together, they are going to be separated like this. Is everyone clear with the working? Any questions? Okay. Moving on. 4 letters are selected at random from the 9 letters in the word Andromeda. Find the probability that this selection contains at least one D and exactly one A. At least one D and exactly one A. And 4 letters are selected. Exactly one A and at least one D. exactly one A and two Ds. Okay. Now, you can't have another A or D over here. So four letters are gone out of the remaining. Okay. So cancel out A's and cancel out D's. What can we do? You can out. So this is what you should do. Out of these two A's, any A can come over here. Okay. So that is 2C1. But since it's a probability question, we have to select the repeated letter as well. Out of two D's, any one D can be accompanied. And out of the remaining five letters, any two letters can be selected. So that is going to be 5C2 into 2 into 2, that is 40 selections. For the second case, out of two A's, any one A can be accompanied. Out of two D's, you're going to select both D's. And out of the remaining five non-repeated letters, you're going to select one letter, that is 10. So there are 50 possible selections. But wait, we do not have to find the possible selection. We need to find the probability. Probability would be favorable outcome divided by the total outcome. Total number of selections without any restriction would be that there are 9 letters, select any 4 letters. So that is simply 9C4. And what is 9C4? 59C4 is 126. So the probability is 50 upon 126. If you simplify this, you get 25 upon 63. That's the answer. Please let me know if you want any further explanation on this. Are we clear? So this was October-November 2023 variant 5.2.